just to be clear, this is not a pure Fireside Chat where me and Bjarne are talking and I'm asking questions for you guys. You can also ask. We should have a runner with a microphone that is going around in order to ask questions. And if not, please raise your hands and just speak out. I will just repeat the question for you in order for everyone to hear it. Let me just sync my notes. I will get my laptop. One second.
Oh, there's the mic.
Yeah, I saw the runner. Okay, so if you have questions to Bjarne that you want to ask, just go out, shoot. We will answer almost any question, but I will maybe start with one question before that. I think whenever I start doing these days something, the main question I ask, like, what's the main driver for me? And I think you said that you started in academics developing C++. That's what I kind of got in the first few slides. But like, what's the first, like, initially, like, why did you start working on it? Like, what did you want to solve for yourself back then?
Okay, I was working at Bell Labs, which was the best industrial research lab in the world, and there's nothing like it today. And there was really good people. Some wrote academic papers and books, but they were in industry. We had a lot of input because Bell Labs were building the telecommunication system for North America and most of the world, really. And I arrived there as just after my PhD as a young researcher, and I went around looking at the doors and saw the names of the doors, and this was really scary. I mean, there was Dennis Ritchie, Ken Thompson, Brian Kernighan, L.A. Ho. It carries on. So I decided I had to do something more spectacular than I had expected, because otherwise I didn't belong here. And so I decided I was going to build a distributed Unix. And if I had managed, I would have been 10 years ahead of what actually happened, a Unix cluster or something like that. But I had, during my PhD, realized that there was no language that could do both abstraction and hardware manipulation. Mm-hmm. And to build an operating system, especially a distributed one, you have to have both. You have to write your process schedulers, you have to write your device drivers, you have to write your communication channels. But then that's low level and very heavy on knowing your hardware and getting the most efficient stuff out of it, otherwise you'll get outcompeted. But you have to raise the level of abstraction. You have a module here, and they have to communicate in some way. And you can't rely on a rat's nest of pointers into memory, because you don't know if they share memory. Mm-hmm. If it's a cluster, they don't. And so you needed the low level and the high level. And no language had it at the time. And today it's still not that common. And so I built one. I knew the high level stuff from Simula. I was on the same corridor as Dennis and Brian Kernighan and such, so I had the best support ever for C. And so I used those two. That's where it started. Very early on, I decided that C needed function argument checking and such. It didn't have it at the time. It was incomprehensible. If you write C today, you're writing using syntax and semantics I introduced back in the early 80s, and it became standard in the late 80s. And the Simula classes and such came in that way. I needed generic programming, so I unified the way you make notations for types and that and how you manage the resources and such, and that later became generic programming in C++.
I have a follow-up question, but maybe we'll get the question from the audience first.
Yeah, thanks for the answers. I will try to have a red line. We have a lot of C++ classes we are serializing to JSON, so we can write them to files, databases, or APIs. And we currently use macros and boost macros to build something like reflection. And we are aware of, we are trying to get rid of the pre-compiler, which will not work if we have a lot of macros. So would you have a suggestion which way we should look at if we want to try to serialize C++ objects to JSON?
Yes. C++26 is getting static reflection, which basically means that you can ask the compiler any question that the compiler can answer, which is sufficient for you to generate JSON out of any C++ class. And you can try it today. There's 2 implementations available at Godbolt at C++ Explorer, one from EGG and one for Clang, so that you can test it out. And well, it is only 25. In 26 it'll be standard, but you can start experimenting today. I have another talk, but again, not enough time. But look up static reflection. A lot of it came out of the work of David van der Voorde from EGG, and look at Compiler Explorer and try it. You're not the only one who has suffered from that. I looked at reflection a long time ago. I had 2 problems with it, reflection as I saw it in something like Java. First of all, it demands a lot of memory, and for generic program, for embedded systems, that was far too much memory. With static reflection, you generate exactly as much data as you want. Secondly, static reflection is type-based, and at compile time, with the compiler knowing the types of things, it is not a graph walk in an untyped system that you get with reflection or with macros. So I love this question. It's so nice to be able to give a concrete answer.
Thanks, great.
More questions like that, please. Even though I feel like we're getting into a consultancy C++ session here. But, okay, so follow-up question. Like, what was the first science back then that you had, like, that what you did, like, solve, like, a major problem? And where, like, what was the first, basically, so you didn't develop this, I would think, as, like, okay, so this is going to run basically 90% of the world at some point. But, like, what was the first indicators where you had, like, this experience and saw, this is really, like, getting somewhere, and you know what I mean?
Yeah, I know what you mean. I don't really know, because I got very, very busy in the 80s. And I was the language designer, I was the compiler implementer, I was the help desk, I was the teacher, and also the author. And sometime in sort of the late, in the early 70s, I realized, wait a minute, I've done something. In between, it was more like, wow, I can do linear algebra better than Fortran. This is good. I eliminated more temporaries than Fortran could, and the fact that Fortran could do arithmetic faster didn't overcome the fact that it had too many temporary variables. So I realized individual things was cool and interesting and important, but the big picture, I was busy. Oh, I was also having little children at the time. It was very busy.
So you continuously, like, always had this, I mean, all the other programming languages that were around back then, I think, what was the, I mean, obviously C, but then also, like you said, Fortran. And, like, how did you go about the features that you selected. And I also wrote down, like, I cannot imagine how this whole process with the standards committee is working. Is it like they how is the engagement? Because I think like they want to keep it as stable as possible, and on the other side, you want to push features that are kind of improving the thing. Like, how is the process there?
Okay. In the early days, it was relatively simple and unstructured. It was just me. And people came and they said, I need this facility. So operator overloading was something that people building hardware needed. The original operators was and OR and XOR because that's what you needed for hardware. And then I have a tendency to generalize. So I mean, if you get and OR, you need plus and minus. And while you're at it, let's get subscripting and application. That's how you got the function objects. So basically, a basic computer science training taught me to abstract, and Simula taught me partly how to do it. And I missed the generic programming, so I put it in because it was the idea that user-defined types behave different from building types was just wrong. And ideally, the built-in type should be examples of classes that just had been implemented in the compiler. And we got these horrible two-way conversions by integers and floats, and it's horrible. I have a talk about how to get rid of that today, but getting rid of anything after decades of use is really hard. People don't imagine how hard it is. I remember wanting to get rid of a feature, and the guy from Sun in the standards committee says, well, you know, if you do that, it'll cost my company $1 billion, and we're not going to do it. Whether the standard says so or not, we are not going to do it. Oh, yes, okay. And by the way, the standard started by 3 people coming into my office at Bell Labs, representing IBM, Sun, and HP. Oh. Those are the 3 biggest computer manufacturers, software manufacturers at the time. And they said, okay, Bjarne, you want to help us standardize C++ under ANSI rules. I said, no, can't do that. We're not finished. C++ is designed to evolve, and we're nowhere near where I would like it to be. And I said, no, you don't get it, Bjarne. We cannot have our companies depending on a language that is controlled by a potential competitor, AT&T, you work for. Of course we trust you, but you could get run over by a bus. This is a direct vote. Oh. And so they twisted my arm for an hour, and I said, yes, I really want to help you standardize C++ under ANSI rules. By the way, what's ANSI rules?
The ANSI what? Sorry.
What is ANSI rules? I agreed to it before I knew what the rules were. I didn't have a choice.
Yeah, but...
And so this actually worked better than you could expect for at least 10 years. These days, I would say the committee is in deep trouble. There's in particular too many people in it. Last I counted, it was 527 members. And there are, I don't know, 25, 28 countries voting. There's more than 100, more like 200 people voting for everything. And there's some big egos, and there's a lot of people with ideas about what a language should be, which doesn't fit with the whole design of it. So it's very difficult now.
That sounds super stressful to just having to like discuss the whole thing. I mean, how you can get 500 people.
These are not stupid people. That is the problem.
Yeah, that's what I'm.
They by and large care a lot for what they are doing right now. A lot of people are really good developers, but they are trained to take instructions from executives and managers and do what they are told as quickly as possible. Mm-hmm. They don't like dawdling for a couple of years or even longer for what I did for generic programming to 2 decades. They're told that it's horrid. You put in a solution immediately, and sometimes it's just blocks the correct solution in the long run. So it's very difficult. And it's more political and managerial than technical stuff that I like better. I'm not a good manager.
But okay, I have so many more. Again, you can ask questions. If you have questions, please raise your hand. Yeah, next question.
Hello, and thank you so much for the talk. I want to follow up on the comments or remarks that you have made about the standard committee. I have had the honor to have a colleague from the standard committee, and I learned that, yeah, there's a lot of drama and politics involved. I'm curious about one particular instance, which is the garbage collector API. Which when I was first starting out with C++, it was something so new and it was kind of hyped. And I think very recently it was removed from the standard. So can you give us an inside view at what was happening inside the committee? What was the motivation for the garbage collector? And why was it removed eventually?
I can do that. At the time, I thought that a large number of users could use garbage collection, and a large number of users couldn't, especially the embedded industry. You really don't want the garbage collector to do a cleanup while you press the brakes on your car. So I was in favor of optional garbage collection. And we had conservative garbage collectors that worked pretty well, and they were used mostly for what we call litter collection. That is, you have a system that has a leak somewhere, and it runs for a week, and you are in the business where you can take your system down on Sundays. Everything's fine. It has enough extra memory that it doesn't break till Sunday, and you bring it back up again. It's called system rejuvenation or something like that. And then you get more users, and it starts breaking down on Fridays. What you do is you plug in a conservative garbage collector with a built-in leak reporter. So when it finds something that hasn't been cleaned up, it reports. And so you can fix it. And that went away. Then after a while, the leaks go away because you've detected them. We built an interface for that. And then after about 5 years, we found that nobody was using it. That is, they used litter collectors, not as much as we had expected, nowhere near as much as we expected, but they used special interfaces. There was 2 major implementations, probably more, but these 2 didn't have the same interfaces, and they swore blind that the standard interface was not as good as their interface. And so we decided we couldn't standardize that. There wasn't a standard, there wasn't an agreed upon standard, and so we took it out. It was not very used, and where it was used, it was not standard.
Okay, next question, maybe, yeah, from the audience. As long as we have stuff from you guys, then that's great. I have a lot of questions.
You said multiple times that C++ was designed for evolve it, like from the beginning. I find that very interesting because I think languages do not really evolve over time or rarely, but C++ does. Maybe my question would be, did it end up like you envisioned it from the beginning when you thought, okay, I build a language that will be enhanced? Or was it turned out differently than you expected?
Two things here. I had some reasonably grand ideas about C++ from the beginning. Like, I didn't want resource leak. I didn't want to break the static type system. I wanted to be able to abstract just about anything and have good interfaces. These are grand ideas, not really mine. You look at computer science, people want something like that. Now, I was just a single person, a researcher. There was no C++ project. And so obviously I couldn't do that. So I had to develop an idea, a strategy that says, I want to get over there, roughly, as I figure out exactly how to do it. But I can't do it now, so I have to move in that general direction while learning and putting in things so that I don't block the right solution and so that it's useful now. The slogan was better code now. But there was an aim out in the future. And you can look that in my early papers. It's there. So I knew something about where I was going, and I knew I couldn't get there directly. I also had some vague engineering ideas. I mean, when you engineer something properly, you do the best you can, then you observe what works and what doesn't, and then you build a better version. Feedback is absolutely critical for real engineering. And I think language design is more engineering than math. And there I differ from a lot of language researchers.
Thanks.
Okay, I think we had another one, but I will ask one of my questions as well.
Okay.
So what you just said, like it's shipping a language is most likely like incredibly hard. And what I wanted is, obviously not with the committee, but like early on, did you ever ship something, not that was not used, but where you unintentionally broke something? Like, is that even possible when there's like so many things depending on it? I mean, it's in the end, everything is.
I must have, but I can't recall something that got out and was really destructive. I was rather keen on compatibility, and where things usually break is when people have violated the rules in the previous version and the checking becomes better.
Ah, okay.
So that's where the next release breaks the previous one.
Yeah.
It doesn't actually break legal code, but people write code that do things they shouldn't.
The compiler gets more strict on
And
what.
now the compiler catches it.
Yeah.
And the other thing is that sometimes things like operating systems and libraries are just, they change faster than languages. People always complain about complexity of languages, but try and look at your operating system.
Yeah.
It's less compatible and more complex.
Yeah.
I remember once where we almost did a major goof. That is, we were shipping, I think it was 2.0. So the next major, the first really major change.
When was that? 2.0?
87 or thereabouts.
Okay.
Plus minus a bit. And after we have shipped, but it hadn't reached the users yet. This was in the really old days where people got Mac tapes. We spotted a bug. And what we did was we fixed the bug and changed the release number to 2.00 so that we could recognize if somebody has gotten hold of the original one. And this was known as released 00. Yeah. But we caught that one just after the last minute.
So I think that's a good example. Like everything is code and everyone makes mistakes. You just have to fix them. There was another question. Yes.
Thank you so much for your talk and also the outlook what is upcoming in C++ 26 and beyond, especially with the memory safety and what you're planning there. I'm a roboticist and I would consider C++ being our standard language everywhere. But I see that a lot of people are nowadays pushing for using Rust instead of C++. So what are you telling those people? Is it the wrong choice? Is it now the right choice and wait for the features? Or what's your point on that?
There's always been people wanting to replace C++. And I'm walking around with a big target on my back. People know all the problems with their old languages, and they usually a new language come in and solve a single problem. And to be a general purpose language, you have to cover many areas. I was asked about this some time ago, and I used CERN as an example. They use serious scientific computation. They use visualization. They use experimentation with data sources, with an interpreter. They use hardware controls up to 0.99999 of speed of light. The point is that big organizations need not just to be good at one thing. And C++ has grown to be too large for any one use, but it can cover the combination of needs, and for that it is good. Currently, there's at least a handful, probably a dozen languages that wants to replace C++. It's not just Rust, it's Go. Some people actually go for Python, which usually live on top of C++. There's Swift, there's something called Carbon. In other words, if you don't have C++, you'll need maybe 6 other languages to compensate. And why 6 other languages are easier to manage than one language that's, well, 6 times bigger, I don't know. In theory, you could have it if they interact well enough, but they don't usually. So I'm obviously biased and prefer to stick to C++ and support what I think of as my users, even though they are not my users. And if people find that something is better for what they are doing, feel free. I don't take part in language wars.
I actually also had the Rust question right next to it. I think that was very obvious, but thanks, Julia, for the question. We also have a talk from CERN actually on doing how they do particle physics analysis later today here at code.talks from CERN, someone, because you just mentioned CERN. Okay, so I mean, I understand what you said about Rust versus C++, but I think Rust has become so, I don't know, it's like a very sexy language for a lot of people for some reason.
I mean, there are people doing Rust seriously, and then there's the Rustafarians.
Yeah, but
which is a cult. And they are better at propaganda than C++ is. They are better organized and all of that. But look, I've got enough to do without the language wars. I keep busy.
I don't want to push any wars because I think we have enough of them at the moment. But I was just wondering, did you try Rust?
Yes.
Okay. What did you think of it? Like, is there something where you were like back, for example, with Fortran, what you said, like there was a feature and you were like, we should do that in C++ sometimes? Or where you had like, they doing this?
My conclusion was that it was focused on one thing and they were solving one problem.
Yeah.
And there was more problems than that.
Mm-hmm.
So I wanted, from actually before I knew Rust, I wanted something like profiles, which is enforced guidelines. And the general idea is that there's different needs in different industries, in different applications. And I came up with that list of core things I wanted to check. And everything Rust can do is in that list, and that's older than Rust. It's just that convincing a standards committee is very hard, and convincing a corporation to build something new is very hard, because corporations by and large want to support what gives them a differential advantage to other corporations. And so helping a language that everybody can use is not always easy to get them to do. So I find that we are at least 5-7 years behind where we should be in terms of enforcement of profiles.
Yeah, I wanted to ask about that on the progress and how much that is stifled, because I think that's also maybe an advantage that Rust has, that they can move faster now because they don't have that many things running it yet. So
That's right.
But we have one more question, and then I have one more question, because we have only time for 2 more questions. But yeah, who wanted to go next? No one? We have like a bunch of questions. We have one up front here. We have one back there.
Thank you, Bjarne, also for the very accessible talk, I think. You had to skip over concurrency, so maybe you can use this to answer my question. It's about the role of mathematics and semantics when defining the language. So if we look at the C++ memory model, for example, the definitions are written in pure words, and this has led to implementations that do it differently because people looked at these words and interpreted them differently, and then it makes it difficult to write, for example, model checkers that explore whether I actually have a data race-free program or whether my parallel data structure behaves the way I want to. Do you think, on a high level, we should bring more semantics to these like standardization committees, even if that means less people will understand them?
I mean, less people might be an advantage, but we tried repeatedly, and the committee couldn't do it. It may be lack of mathematical maturity, but it's also that it is difficult. A lot of the formal mathematics means that you have to go away from the hardware, and C++ has to manipulate the hardware. So we have had things that was done formally. The memory model was done formally, that's defined in math. The initialization and constructor-destructor stuff has been formalized in cog. But the whole language isn't. And if you look at the academic languages, by and large, they don't have a mathematical definition. They talk about it, and they have experimental versions, and some academic papers talk about it, but they are not precisely specified as much as you would like. And C++ isn't either, but we have gone some direction in that, some way in that direction, and found we couldn't complete. I mean, ML used not to have a formal grammar for almost 10 years. At least we had that.
Okay, there was another question somewhere, and that would be the last one. I just have one final one after that.
Hi, yeah. Thanks for the talk and everything. So I was wondering, how do you see that for C++ we have different kind of compilers, while for Rust or something I mostly see one compiler, and regarding the speed of taking in actually the features that we have in new C++ versions, sometimes takes a while. Like 2 years ago I tried to make a talk about C++ modules as at a local meetup, and was a little bit frustrated because I couldn't make it run. So what do you think about the advantages and disadvantages of having different compilers?
I am not in favor of monocultures. Everything is easier and faster in a dictatorship. There's only one way, and everybody has to do it the right way, and you can change it. C++ is not a monoculture. If one compiler, if one company doesn't support their compiler, then somebody else will take up the slack. This has happened repeatedly. And so I'm in favor of multiple compilers. You also find that it covers a larger set of hardware and it finds more bugs in the definition. So yes, it's a pain in the neck to deal with 3 or 4 compilers and a dozen backends, but it's a net advantage.
Okay, I'm sorry we don't have time, but I think Bjarne, you will be around afterwards as well. I think we have a small interview after our session here, but I think you will be around and people can ask you questions.
Yeah,
I think
I'm around today.
okay, great. And yeah, so might be scary, but you can still ask him questions wherever if you see him, but maybe not all at once. So my last question is, I guess if you invent something that's running basically everywhere, or how you would imagine it, I would try to at some point invite the person to something where they can see like this is what you have done for us, right? Like that's like let's say for example CERN where they are running C++, or I don't know NASA when they are running it, and did it happen that they invite you in order to like, so this is what you've done for us? And what was the coolest thing that where that happened?
I mean, what keeps me going is to go and see what people are doing. And yes, I've been to CERN a couple of times. Yes, I've been to the JPL a couple of times and been in the control room for the Mars rovers and things like that. So I've been to the Formula One building place and been to bank, been to graphics organizations, games. Yeah, it's fun.
That's so cool. Okay.
And also, how else would I know what the problems are? And what they can use and what they can't.
Because you're talking to them, you mean?
I have to talk to the users.
Yeah.
It's the only way I know.
Okay. Thank you so much for being here today. And thank you for all the insights and just in general for C++. I think you got it a lot. Yeah, like I said, I think Bjarne will be around, so ask him questions if you want, just not all. If there's a pile, stop, like maybe later. And yeah, thank you so much.